Hello everyone, Ron again, and in this video we're going to talk about LFOs, what they are and what they do. So this one is going to be real simple because LFOs are by far one of the simplest topics. So LFO stands for low frequency oscillator. If you know anything about an oscillator or what it means to oscillate, is just to move back and forth. You can set a fan to oscillate and it will just blow back and forth. This is the same idea, except we're going to show this in the context of a filter, so that if you were using mini synth, for example, or a synthesizer, you could understand what would be happening here. So there are different parameters that you can cause to oscillate. And essentially the idea is that you want to make it move back and forth predictably. That's the purpose of using an LFO in a nutshell. A lot of the time when you are synthesizing, you're going to modulate the filter cutoff to change the timbre, but obviously here you can modulate the frequency. Think of a police car, wee wee wee. That would be a pitch oscillation or frequency oscillation, and the oscillation of the modifier is just something that you would want to play around with. It's too complex to explain, but we're gonna stick to the simple thing in the filter. So you have different shapes in which the oscillation can take form. So the first one we're going to look at is a sine shape or a sine wave shape, or however you would like to say it. And as you know, if you've ever taken calculus or like pre-calc, I guess, a sine wave is going to go from 0 and then it has an amplitude of 1 usually in a basic sine wave. So it goes up 1 and then it goes back to 0, then it goes to -1, it goes back up to 0. So that's what the sine wave modulation in an LFO is going to do. It's going to go from the low point to the high point continually in a smooth fashion, and then it's going to come back like this. And with regard to amount, that's the amount that it will move, but in this case it's called volume in this one. And the base is the regular set amount where it would be if there was no modulation. So that's where it starts. Volume or amount is how far it's going to move. And as you can see, the sine wave is going to go steadily back and forth, and it's just going up because the volume is up. If I switched it to down, then it's going to go down, which in this context makes the filter close. So that's easy to understand. Let's look at the next one. The next one, which you will see up there, would be a sawtooth wave. Sawtooth wave is exactly what it sounds like, shaped like a sawtooth. You know, think of if something carnivorous bit you, like a, what do you call it? A canine tooth. That's the idea. And it's going to go from min to max, and then it's going to go back down however quickly it's set to go back down. Because you can make it go back down instantly, where right after it hits the max, it automatically goes back to the minimum value. Or you can make it reduce gradually. So you're going to see here, I'm going to move this down. It's going to make the volume, it's going to make the filter cutoff go up and then quickly come back down. And in this context, how I would change that is tension. Tension controls how fast or slow it goes back down when you use Fruity Peak controller. And you can see the shape of the wave changing right here. So it's going to show you visually what it's actually doing. And it's the same if I switch it to a sine wave. It shows you the sine wave and it visually matches the way that it is moving over here. So not too complicated so far. And the last one that we're going to look at in this video is a square wave, because that's the last one that's here. So a square wave does not go in between the min and max volume. It just does the minimum and the maximum. It only touches those 2 points. See? You can see here that it's a square. It goes max, min, max, min. There's no gradual reduction. is just straight from the max to the min. And that's simple enough to understand, you know? Now, if you're from New York and you were like, you're speed that up, then it would move a lot faster. It eventually moved too fast for your eye to see. And in some contexts, it might move so fast that it would not sound good. And that's that. So that was a brief overview of LFOs and what you would do with them. You can modulate pretty much any parameter that you want. So, get creative and figure out some way to make some cool sounds, because you don't just have to use filters, as I said. And there are some effects like flanging, which I believe flanging comes from the modulation of like the delay value of an actual delay effect. I forget. I have to research it for whenever I do a video on it, but I forgot exactly how that came about. It's another thing where the history of it involves the analog world, so it's kind of fascinating. But we'll cross that bridge when we get to it. So with that being said, that's all for today. And as usual, have an awesome day.